So, for instance, I'm sorry they're not numbered. I'm going to skip this first one only because it's involving trig. And I don't want to start off with trig problems, okay? So we're going to jump down to the second one. All right. And it said, which of the following is the particular solution, y equals f of x, to the differential equation? When we have a differential equation and we're trying to find the solution to it, is there a problem? Focus, 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 focus. When we have a differential equation and we're asked to solve it, then that means we're trying to solve for y. So in other words, get it to be y. And if we look at this, it's dy dx. So what's the first thing we do before we can actually make that a y? So basically separate the variables, separate the x's and the y's, all right? So looking at this, I want the y on the left and I want the dx on the right. So it's going to be 1 over y dy. Yes, sir.
Would you mind if I sat in the hallway and do my work because my headphones can't hold the charge anymore, and I would like to listen to the AP video.
You can probably go down to the comments if you want. Yeah. I'm dividing by y on both sides. Right, I've got dy dx equals y over x, right? So if I multiply by x, dx on both sides, I get dy dx equals y over x dx. I need to bring that y over, so I have to divide by y or multiply by 1 over y. Okay? So I'm going to end up with 1 over y dy equals 1 over x dx. So we're separating our variables. Okay? So what would we do now? Now we integrate. Because I want y equals, not dy. So we're going to integrate both sides. What's the integral of 1 over y? Natural log. Remember to put that in absolute value because I don't know the value of y at this point, and we can't take the natural log of a negative number. And then the integral of 1 over x is the natural log of x, and we're going to do plus c. Right? Okay. How are we going to find out the value of c? Yeah, I'm going to plug this stuff right here in. So this means when x equals negative 1, y equals 2. So I have the natural log of 2. I don't have to worry about the absolute value anymore because 2 is a positive number. Absolute value of 2, the natural log of 2 equals the natural log of negative 1 plus c. So that means I've got the natural log of 2 equals the natural log of 1 plus c. What's the natural log of 1? 0. Natural log of 1 is 0. Remember, natural log is log base e. So what would I raise e to the power of to get 1? And that would be 0. So that's one we have to have memorized. Natural log of 1 is 0. So this means a natural log of 2 is what c equals. Okay, so I have the value of c. So I'm going to go back up here. Don't forget to put those absolute values back in there. Natural log of x plus the value of c is the natural log of 2. At this point, this is where most people make a mistake because many people stop right here because you feel like you've solved it. You feel like you finished because you did your integrals. Excuse me. You got your c value and you plugged it back in and you're patting yourself on the back and your grader is going wrong, right? So what are we missing? What are we looking for? Y equals something. Do I have y equals?
No.
No. So now we've got to do more algebra work. Okay, so we're going to rewrite this. I'm going to use an uppercase L just because it gets a little hard to see. We're going to rewrite this. When we're adding logarithms, what were the originals? You multiplied them. Okay, so when we multiply, we can expand it by adding. When we're adding, we can condense it by bringing it back to a product. So the natural log of x plus the natural log of 2 is the natural log of 2x. That's one of our properties. Okay, well, if the natural log of y is equal to the natural log of 2x, what does that mean? Y equals 2x. Okay, now let's look at our answers. We're real close. So how do I figure it's 1 or 2, right? It's either 1 or 2. But you notice there's a negative number, negative instead. Well, if we look at the given information, when x is equal to -1, y is equal to 2. That means when x was less than 0, y was greater than 0. Well, look at my options. Here's where x is less than 0. If x is less than 0, does this give me a y that's greater than 0? Yes, it does. So that's my answer right there. Okay, I want you to look at the next one and try to get going on that one. See how far you can get. Okay. Okay, so we want to isolate those variables. So when I multiply by dx on both sides, I get dy equals xy over x squared plus 1 dx. We don't want to have 1 over dx. We want that dy and that dx to be just perfectly normal. Okay, so that means I'm going to have to move this y over. So I'm going to multiply by 1 over y on both sides. Okay, so I have 1 over y dy equals x over x squared plus 1 dx. Okay, now we're ready to integrate. So on the left, that's no problem. I have the natural log of y. But on the right, I have a problem. Okay, I can't just do, if it was just x over 1 in the denominator, I could just do the natural log. But it's not, it's x squared, right? So let me work backwards. Let's pretend that you thought it was a natural log of x squared plus 1. Well, let's take the derivative of that and see what we get. Because when we take the derivative, we should get that, right? So the derivative of the natural log of x squared plus 1 is 1 over x squared plus 1 times what? 2x. The derivative of that, which is 2x. That gives me 2x over x squared plus 1, and that's not what I have. Okay, so I've got to do something different. So what I'm going to do is that u substitution. So I'm going to say let u equal x squared plus 1. And my goal here is to get an integral of 1 over u du. Because we know the integral of 1 over u du is the natural log of u. That's my goal. So I'm going to say let u equal x squared plus 1. Then du would be 2x dx. Okay. Well, I have an x dx. I'm going to put a 2 there. But remember, you can't just randomly put a 2 there, right? So if I put a 2 inside, in order to balance it, I have to put a 1/2 outside. Okay. So now I have 1/2 integral of 2x over x squared plus 1 dx. based on this information, I can rewrite that as 1/2 integral 1 over u du. Because what does du equal? Du equals 2x dx. So here's my u down right here, x squared plus 1. So 1 over u times du. Well, du is 2x dx. Does everybody understand that? Okay. Yes. It's really intuition. Okay. So and I know, and that's frustrating. But as we do more, it'll come more natural. So when I looked at this, what jumped out at me, what I saw right away, was that the derivative of x squared is 2x. And I already had the x. If you have the variables and it's just the numbers that are off, you're in good shape. It's when you're missing the variable. Like if this was just a 1 on top here, we'd have a big problem. We'd have to use a special formula that we're not comfortable with yet, right? So, but I had that variable, I had that x there, and not only did I have the x, but I recognized that the degree on top was 1 less than the degree on the bottom, right? When we take the derivative, that's always going to happen. You're going to end up with one exponent lower, 1 degree lower. So when I looked at this, that was what I looked at. I was like, okay, this is not a clear natural log, but I saw that I had the x there. I was like, okay, I can do this then. Okay. All right, so now we've got it in that form. So now we know we can take the derivative of that and get natural log of u. So plugging the u back in, we have this equals 1/2 natural log of, and what was u? X squared plus 1. Do I need the c value there? I mean the absolute values there? No, I don't, because it's squared. Good. You don't need the absolute value because it's squared. Okay, who has questions on the u substitution there? Yeah, Faith, what's your question?
So is the goal to always match the time of it with the derivative, the du?
Yes, in this, yes. Okay. Because remember that 2x over x squared plus 1 dx, right? That's the same thing as 1 over x squared plus 1 times 2x dx. That's the same thing. Okay? Okay, so now we've taken the integral.
If you have a natural log say equals to a natural log, you can't cancel it out, right? Natural log.
If there's nothing else, if it's just natural log equals natural log, like we had up here, natural log of y equals natural log of 2x, you can just drop off the natural logs. Yes. Okay. Okay, so now we need to figure out the value of c. And it says y of 0 equals 1. So that means when x equals 0, y equals 1. So we have the natural log of 1 equals 1/2 natural log of 1, because 0 plus 1 is 1, plus c. Well, what's the natural log of 1? 0. So 0 equals 0 plus c. So c equals 0. Okay, we're not fully there yet. Again, don't stop early. So we have the natural log of y equals 1/2 natural log of x squared plus 1 plus 0. But I haven't solved for y. Okay. Solving logarithmic equations. It's coming back to haunt you. Okay, we're going to multiply both sides by 2. 2.
Can't you just drop the natural log?
We could actually, wait a minute. No, we can't drop them yet. So I multiplied both sides by 2. You don't actually have to do that. You can bring that 1/2 back there. So let's say a natural log of y equals a natural log of x squared plus 1 to the 1/2. We could bring that back up to the exponent if you want. Now we can drop our logs. Be careful with that absolute value. Absolute value of y equals the square root of x squared plus 1. Okay. Any thoughts here? Because do I see that choice there? Yes, I do.
Yeah.
Okay. So our answer is B. Okay. I thought I didn't see that answer there.
That wasn't a good one, Ms. Murray. Can you do it again?
That's an on top.
Thank you. It sounded sad.
It did sound sad. You just missed so much. Oh my goodness.
Oh, Jordan is really.
Okay. Jordan was having a
I remember
went into cardiac arrest.
He was scared you weren't here.
Okay. Questions on the first, there's 2 that we just did. We're going to go back up to number 1 now. And we're going to do that one. Okay. This is pulling a lot of stuff together. We're getting hard now. We're getting hard. All right. Let's move up to number 1, the first one there. Okay. Same type of problem. It says y prime. Y prime is the same thing as y, right? I mean, it's dy dx. So basically we have, I'm going to write it as dy dx. What is the value of y of pi over 2? Okay. So if I want to find the value of pi over 2, I need to find the equation for y. So I need to do the same thing here again. Okay, so question? Okay, so we're going to multiply both sides by dx. 2 cosecant squared x minus 3x squared dx. Okay, and then what? Yeah, we're going to integrate both sides. Good. No, we don't have to do that. You don't have to separate a polynomial. You can, but you don't have to. And since it's all in terms of x, we can leave it over there. So we're going to get y equals, all right, what's the integral of cosecant squared? Look at you guys. Good job. So this is going to be negative 2 cotangent x. The derivative of cotangent is negative cosecant squared. Since this is a positive cosecant squared, we have to have a negative cotangent. Okay? And then we're going to do minus. Now, what's the integral of 3x squared?
X cubed.
X cubed. Look at you guys. I'm proud of you. Plus c. Okay? Now what?
Now we plug in.
I need to figure out c, right? This is a non-calculator, by the way. So I'm going to use this information to figure out c. Non-calculator here. Okay? So when x equals pi over 4, so y equals pi cubed over 8. That's negative 2 cotangent pi over 4 minus pi cubed over 4 cubed, which is 64, plus c.
Because it's x to the third, so it's pi over 4 to the third, which would be pi to the third.
Okay. What's the cotangent of pi over 4?
Would be the cosine over sine.
It's x over y, which is 1. Yeah. So we have pi cubed over 8 equals negative 2 minus pi cubed over 64 plus c.
Oh, that's the
Oh my god.
well, I asked.
It's okay.
So I'm gonna get this pi cubed over 8. I'm gonna get a common denominator. So 8 pi cubed over 64. I'm gonna write it like that because I want to combine those pi cubes. And I'm gonna add pi cubed over 64. And I'm gonna add 2. Whoops, that was weird. Why did my brain do that? Plus 2 equals c. Okay, so I get c equals 9 pi cubed over 64 plus 2. That's what c equals. And these are really ugly numbers, but when I look at the answers there, it's like, okay, they're ugly also. So I'm okay so far. Okay, so y equals negative 2 cotangent x minus x cubed plus 9 pi cubed over 64 plus 2. This problem is harder algebraically than it is calculus. Okay? I just found C. This is C. Okay. What do we do now? It's asking for y of pi over 2. Caitlin? Solve for y, yeah. So y equals negative 2 cotangent pi over 2 minus pi over 2 cubed plus 9 pi cubed over 64 plus 2. Don't panic when you see all these nasty numbers. Don't panic. We just keep moving through. Okay, cotangent of pi over 2. Pi over 2 is right here. This is 0, 1. Cotangent is x over y, so what does that equal? 0 minus pi cubed over 8 plus 9 pi cubed over 64 plus 2. So I need a common denominator again. So that's going to be 0. So I'm going to write negative 8 pi cubed over 64 plus 9 pi cubed over 64 plus 2. So y equals pi cubed over 64 plus 2. Dun-dun-dun-dun-dun.
For a difficult problem.
Okay, all 3 of these problems, we've done the same thing. We separate our variables, we integrate, we use our initial condition to figure out C, and then we substitute the C in, and we solve for Y. We did the same thing in all 3. separate the variables, integrate, figure out C, plug the C in, and solve for Y. Okay?
I don't think we'll grow this.
Okay, we're going to skip the last one on that page for now. We'll skip number 4 for now. Okay? Okay, I would like you to try to do the number 5. Try to do this one. I'm sorry they're not numbered. Try to do that one on top. dy dx equals 6x squared plus x over y. And not be being silly. This is not a time for silliness. Okay? All right. So what we're going to do, we need the x's on one side and the y's on the other. So I'm going to multiply by dx on both sides. Right? And then I need to get rid of this y. So I'm going to multiply by y on both sides. So we end up with y dy equals 6x squared x dx. So this one's actually easier to integrate. Okay, we're going to integrate both sides. So when we integrate the left, what do we get? Okay, and that equals, we get 6x to the third over 3, so that's 2x to the third plus x squared over 2 plus c. Okay, we're trying to get that y by itself, but we have to find c first, right? So I'm going to substitute in my values when x equals 0, y equals negative 4. So we get 16 over 2 equals 2 times 0 plus 0 plus c. So c equals 8. Okay. So now I have 1/2 y squared equals 2x to the third plus 1/2 x squared plus 8. Trying to solve for y, so we'll multiply by 2. So we get y squared equals 4x to the third plus, whoops, I forgot my squared, plus x squared plus 16. Let me make sure, because I made a mistake there, and make sure everything's okay. Okay, so now I take the square root. So y equals plus or minus the square root of 4x to the third plus x squared plus 16. At this point, I look at my choices. So now it looks like I have to choose between A or B. Any idea how we do that?
Oh, you plug in and it has to be a positive number.
Well, when I plug in my x, what type of y did I get? Negative number. If I plug in 0 here, right, I get the square root of 16, and it told me y is negative 4. Well, the square root of 16 is a plus or minus 4, so clearly we're looking at the negative square root. So it has to be choice B. Okay. At this point, you guys should be able to do these. You should be getting it now, okay? Because I looked at the initial condition. When I plugged in my x value, x equals 0, I got a negative 4. If I plug in x equals 0, I get 0 plus 16, which is the square root of 16. The square root of 16 is plus or minus 4. Since they gave me minus, it had to be the negative one, okay? Okay, let me see here. Let me see if I can find another one for you to do. So give me a minute. I don't have any more like this on that worksheet. So let me see. Um, there we go. Okay. Okay. Hmm. Okay, let's try this one. Let's try dy dx dy dx equals xy minus y. So I want you to find the solution.
Is this like your own problem?
No.
Or just add it to the end?
Just get or turn the page over, whatever, blank page. This is just an extra one. Find the solution. And let's see, the graph goes through the point. To -1. So try that one. Why I can't get this video is not working right here.
You can also just put it. You can just draw something.
Hmm.
We can't leave it as natural log of y, right?
Nope.
Yes.
If it if you have not excuse me, if you have the natural log of y equals something, then that means e to the power of whatever's on the other side of the equal sign is equal to y.
Um, Are we supposed to get a natural log in this?
Yes, I think you do get a natural log on it.
So then we just change it to that, and then we're done.
Okay, let's do it together. So, again, I'm going to multiply by dx. So dy equals xy minus y dx. Now, how am I going to get the x's to the other side?
You factor out the y.
Yeah.
And then divide it
So if I factor out a y, I've got x minus 1, y times x minus 1 dx equals dy. Yes.
So I just like moved the y over and then I divided by y, and that's completely different. So how do you know you can't do that? Because then you get y over y, and then dx equals 1, and then you just get dy equals x dx.
So you added y.
Yeah, so then you get y dy equals xy dx, and then you divide by that y, and then you get 1 dy equals x dx.
You did that, right?
But the dx
But the
is on the
dx
other side.
Yeah, but it's the same thing, and then you divide.
Okay, wait, no, it's not the same thing. Hold on a second. So you did this, you did this,
Yeah.
and then you added y?
Yeah.
But you can't because that dx is times that whole thing.
So you'd be adding y.
You'd be adding y dx. Okay. Okay, so now we're going to divide by y. So we have 1 over y dy equals x minus 1 dx. Okay, so then we're going to integrate. So we get the natural log of y, absolute value y, right, equals x squared over 2 minus x plus c. Got to figure out that c value. So the natural log of negative 1 equals 2 squared over 2 minus 2 plus c. So the natural log of absolute value of negative 1 is the natural log of 1, which is 0, equals 4 over 2, so that's 2 minus 2 plus c. So c equals 0.
Oh, I got it.
Everybody okay? Go
I
up.
just need to catch up with my writing because I had to erase them.
Okay, so we're going to substitute that c value in. So we got the natural log of y equals x squared over 2 minus x. Now it's time to do our solving a logarithmic equation stuff. Okay, so this means that e to the power of x squared over 2 minus x is equal to y. And that is that our answer? That's actually not our answer. And here's the reason. So my choices that are given, I have two choices. One is y equals e to the x squared over 2 minus x. And one is y equals negative e to the x squared over 2 minus x. Which one is it? The second one, because the y is negative. And there's no way I'm going to raise e to a power and get a negative number unless there's a negative in front. Okay, you can't raise a number to some power and get a negative answer unless that number is negative to start with. Okay? Yes.
How'd you reason again that natural log of y is like,
Say that again?
well, what's like the rule for e to that?
How did I get from here to here?
Yeah.
Okay. So the definition of a logarithm, log base b of x is equal to y if and only if b to the y equals x, right, Manny?
Yeah.
Okay. So this is the exponential form of the logarithmic function. Natural log is a log base e. So the definition says if log base e of x equals y, that e to the y is equal to x. So here we have the natural log of y equals x squared over 2 minus x. So that, remember, this means it's log base e of y equals blah, 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 blah. So we put it in exponential form. So that means we take the base of e and we raise it to that exponent, and that equals y. That's the definition of our logarithm.
So that log base e of y is natural log of y?
Yes. Natural log is a logarithm with a base of e. Okay? Okay, let's go back to our worksheet and let's look at some different or additional types of problems. Okay? So let me see. I skipped the equilateral triangle one. Well, let's do the equilateral triangle one now. Okay? An equilateral triangle has an area of, does anyone remember the formula for the area of an equilateral triangle?
1/3.
1/3 what?
Well, equilateral is three equal sides.
So it's not going to be 1/3 base times height, is it?
No, it's 1/3.
The area of an equilateral triangle
Base times side. Notice the side is the base. What kind of a triangle?
equals the square root of 3 over 4 times the side. Now, in this particular case, it says that the side length b, so we're going to call it b squared. That's the area of our equilateral triangle. Okay? If the area of the triangle decreases at a rate proportional to its perimeter, okay, so the area decreases at a rate proportional to its perimeter. Well, the perimeter of an equilateral triangle, how would I represent that? Or in this case, 3b, right? Okay. So the area is decreasing, dA dt is decreasing, so it means it needs to be negative, right? So I can eliminate choice A and B. Okay, if the area is decreasing at a rate proportional to its perimeter, then that means it's going to be K times its perimeter. Anytime we hear that something is proportional, you should be thinking back to pre-algebra, y equals kx. That's your proportional function. K is the proportionality constant. Anytime you hear proportional, y equals kx should be jumping into your mind. So here we have k times p. It's proportional to the perimeter. Okay? Which one of these equations, right? So that means we have dA over dt equals k. What's p? 3b. Which one of those equations follows that form? Choice C or D. So D. So what would the K be in D? We've got negative 3 root 3 over 2b, and P is 3b, so this is root 3 over 2 times, or negative root 3 over 2 times 3b. So the K must be that negative root 3 over 2. That's the K. All right, so it has to be D. We didn't even have to do all that. All we had to do was match it up. It's proportional, and P is 3b. This is the only one that follows that format. It has to be negative because it's decreasing. Right? So we had to choose between C and D, and C, the B was being squared, and that doesn't work. Okay? Okay, let's look at the next one here. If Y of T is the amount of money in an account at time T, which of the following differential equations describes a linear growth, right? So if it's linear, then Y equals mx plus b. Linear growth in the amount of money in the account. Well, if Y is mx plus b, then dy dt, what will that equal? If I take dy dt, what's the derivative of mx plus b? The derivative of mx is m, and b is a constant, so what's the derivative of that? 0. So dy dt equals m. Which one of these would represent that? A. Okay. Okay, we're going to skip that one. That one's a little bit, we're not quite ready for it yet. Okay, here you go. Let's do this one. Okay. Let's do this one. We're trying to find the differential equation that matches this, okay? So we talked about slope fields before, looking for the differential equation that matches it. So look, what points are you looking at that you think that might be of significance?
0.
Okay, so look at this line right here. What's the slope of all of those lines? 0. And that represents the x-axis, which is when y equals 0, right? So when y equals 0, dy dx is equal to 0. Okay, let's see if we can eliminate anything. I can eliminate c, right? Okay. How about b? When y equals 0, so what that means is it doesn't matter what the x value is. When y equals 0, dy dx is going to equal to 0. Will that work for b? No. When x is 3, if y is 0, I get dy dx equals 3. So I can eliminate choice B also. Okay. All right, so I'm down to choice A and D. Okay, so what is the slope when x equals 0? It's not. Yeah, that's not showing that it's a, well, I'm not sure what it is. It's not showing that it's undefined.
Isn't that what the two, like the dots lines on the x-axis?
No, that just means it's a large positive value. Right? It's not, to me, it's not clear that that's undefined there. That could be just a very steep slope. You know what I mean? So I'm not clear. So what I did, okay, I'm looking at it, I'm like, okay, when x is greater than 0 and y is greater than 0, what's dy dx? Greater than 0. So when they're both positive, okay, we get greater than 0. Let's look at when one's positive, when x is greater than 0 and y is less than 0, right? Looking at these slopes, x is positive, y is negative. dy dx is what? Is negative. So when x is positive and y is negative, okay, I have a negative number here and a positive here. Not sure if that's always going to be negative, but if I look at this one, if x is positive and y is negative, this will always be negative. You see the difference? This one on A, if x is positive and y is negative, then xy is negative, y will be positive. This is only going to be negative when this value is larger. Does everybody see that? It's not always going to be negative. But here, dy dx will always be negative. So that's our answer. Okay? So you can reason through that one. Okay, let's go down to this other slope field equation. I think that's all we'll have time for today. Okay, let h be the function such that h of y is greater than 0 for all of y. Which of the following could be a slope field for the differential equation? Okay. So looking at this differential equation, this is dy dx, this represents the slopes. Okay. What do you notice? When x equals plus or minus 2, what does dy dx equal? 0. Okay, so when x equals plus or minus 2, so A is a possibility, B is possible. How about C? No, C is not possible. How about D? No. When x is plus or minus 2, the slope is 0. If you look at A and B, both of these, when x equals 2, all the slopes are 0. It doesn't matter what the y value is. The slopes are 0. Okay? Now we have to figure out which one to use. Any ideas of how to do that? Let's pick an x value. How about when x is greater than 2, like x is 3? Okay, when x equals 3, is my dy dx going to be positive or negative? Positive. Okay, which one of these graphs matches that? A. Yes. Does everybody see that? Say it again. So if you look at choice B, look at the slopes when x is negative 3. All of these slopes are negative. These are all negative slopes. I don't even need to know. I don't need to know what h of y is. I'm just looking at this part right here. If that's negative, then dy dx will be negative because it told me that h of y is always going to be positive. Yes.
So because at 3 it's a positive slope, that means dy dx is positive, so it's...
Yes.
Okay.
Yes. dy dx represents the slope. The slope field graphs are graphs of the slopes, graphs of the slope of the tangent lines. So it's the dy dx. So that's what all these little slashes represent. They're the actual slopes. Okay?
Miss Murray,
Yeah.
can I take the homework quiz out of this Friday?
Yeah. I just want to make sure you guys understand this. I want you to look at this slope field again, okay? This is what's happening with this. Look at the slopes. These are the slopes. These are the slopes of the tangent line. So this is what's going on. It's going like this, right? And then it's got a maximum there, and then it comes back down, right? And then it's got a minimum there, and then it's going back up again. That's what's going on with that line. Okay? Okay, you can see what's going on with the graph by looking at those slope fields. Okay, we're going to stop there for today.